Hey everyone, welcome to the part 1 of high availability AWS series. In today's video, I'm going to show you a step by step on how to create and design the VPC and the subnets which powers everything else. Let's deep dive right into it. As you guys can see, I have created a roadmap. So what are the steps we are going to follow to create or design the network, and I'll be sharing the links in the description below, and the step-by-step Word document in my GitHub profile. I'll link that down in the video as well. Go and check it out. As you can see, we'll be starting off with the phase 1, which would be the network foundation, right? This is the most important one. You guys might be aware of, like, the AWS gives here default VPC, which is not connected to the internet gateway. But keeping that aside, we'll be building it from the scratch. So I'll show you. Start off with the phase 1. The phase 1 would be the network foundation, and first of all, we're going to create the VPC, and then we'll carve the subnets out in that VPC, and after that we'll create a internet gateway and attach that to the subnets or VPC. Let's dive into it. Let's build the phase 1, the network foundation. We are starting off with the VPC, right? So the prerequisites for this is you need to have your AWS account. If you haven't have it before, you can just sign it up. It will ask some documents and it will verify you. You can either give your credit card or a debit card. It will just debit 1 or 2 rupees from your account to verify that you are a genuine user. And for this, you don't need, if it's your free tier account, so AWS will provide you credits with a limited duration of time. If it's not, then it is chargeable. Every service is chargeable in the AWS, so keep that in mind, and let's design the network. We will start off with a VPC. I'll recommend you to not use the root user account. Instead of use an IAM user account, we'll be following least privileges in order to avoid any catastrophes. So yeah, let's build the VPC here. As you can see, I am in my console, right? This is my root account. And also keep in mind that the VPC and the subnets where you are creating, all the services should be in a same region. Okay, please pay attention to that. Reason being, after doing this, if you want to delete the services in order to avoid the costs, and if you have created a different service in another region, it will still be added to your billings. So just a heads up for you guys. Okay, now let's continue with the topic. We are in our AWS console. As you guys can see, I'll choose VPC. We are building the network foundation, right? First we need to create a VPC. I'll be naming the VPC with production Mumbai VPC. The CIDR notation, this is something that every beginner misses, is that CIDR notations, it is a 32-bit network, right? So 32-bit network, from there value negates. As the value reduces, the IP addresses count will be increased. IP addresses, you can see it is basically a combination of 4 octets divided with a full stop, right? Each subnets, each CIDR value or the IP address has 4 octets, which are segregated into the network portion and the host portion. So in order to avoid IP exhaustion, this is the standard in the industry which is followed, that is /16. This is the standard followed in the industry, so keep that in mind. When you are creating a VPC, give it a 16 CIDR value in order to avoid the IP exhaustion. Reason being, if you want to add additional services in future, you will avoid the IP exhaustion error. Less mess is good, right? So you don't need to create another VPC and you don't need to migrate the data again. So future self will thank you for doing this. So use the CIDR notation as 16. Let's create the VPC, right? Here, as you can see, there is a VPC button and I have clicked on that. In VPC settings, it gives us two things, VPC only and VPC more. So we'll be doing most of the work right now, just for the case of explanation. So I'll be using VPC only. Name tag I'll be use prod Mumbai. It stands for production Mumbai, and this is the IPv4 CIDR value. I'll be giving 10.0.0.0/16. Remember that, 16. Okay, now let's just create the VPC. As you guys can see, we have successfully created the VPC. Let me just check it out. This is the default VPC which AWS gives you. The reason being we chose the IP address from 10 is, like, IP addresses are divided into 4 classes in a private category. So it starts from 0 to the range. You guys can look it up. It's available on the internet, so I don't need to get into that. Next, we'll be moving on to creating and carving out the subnets. These are the examples I have created. in order to explanation. The reason being I have taken 1 2 3 4 in this area is being to separate the network part and the host part, because it would be easy to calculate, it would be easy on you. So that's the reason I chose it. And 10.0.1 becomes the network portion. So I think you guys can understand where I'm coming from. It's just to save your from mental stress. If you want to increase your subnets, you don't need to scratch your head all the time to create the subnets. So that's how we're gonna do it. And I'll be carving out 4 subnets for this 2-tier high availability AWS cloud network. 2 are for public and 2 would be private subnets. Reason being public, which as the name suggests, it's gonna interact with the internet, and the private, which is cut off from the internet. That means only we can interact with it. And I'm going to show you how the public subnet can interact with the private subnet as well. Just for the sake of time saving, I'll just copy the names from here and I'll go to the subnets option. As you guys can see it here, these are the default subnets given by the AWS. I'll create a custom one and I'll be choosing the part-1 by VPC. This is our VPC, this is its CIDR value, and we want 4 subnets, right? So I'll start off with the public subnet 1, availability zone. This is the main part. You shouldn't keep your subnets all in the same region or availability zones. Reason being, you want to avoid the single point of failure. Let's say if your server goes down in one region or one availability zone for whatever the reason, could be power shortage or natural disaster, whatever the case may be, you should have a backup plan so that your website's running 24/7. That's that. I'll choose Asia Pacific Mumbai South 1A region for our first subnet, and I'll give the CIDR value of 10.0 1.0/24. This gives us the 256 IP addresses, and that 5 IP addresses are reserved for the AWS. And you can just Google it up why it takes 5 IP addresses. I'm not going to talk about those in this video. And we are done with the subnet 1. Let's just create another subnet, which is subnet 2. I'll just take this value. I'm just being lazy, guys, so don't mind me copy pasting. It is also scale, just paste it here, and that's good. And this should serve as our backup public subnet. That's that. And we'll be moving to create private networks. Now these are the notations I'll be giving to it. This is gonna be number 1, and let me just copy that CIDR value as well, paste it here, and I'll choose the availability zone of on A. Last but not least, and then the CIDR block will be, let me just type it out, 10.0. This is for right 0.0/24. I'll just keep that 1B, right? Now I'll click on create subnet. As you guys can see, it's just like that. In an instant we spin up the subnets and a VPC. As you guys can see, private subnet here and public subnet here as well. We are yet to allocate the route table, so I'll be doing that as well. So moving on, now here comes the internet access. As you guys can see, the next step would be creating an internet gateway and then attaching it to VPC, right? Yeah, here is the internet gateway. This is the default one which was given by the AWS, and we are going to create a custom gateway. So I'll be giving public, this is the name by the way, IGW stands for Internet Gateway Mumbai, and this is that. Now let us create the internet gateway, and it's on. When you click on your actions button, you can see attached to VPC here. From there you can search for it. It is showing me when I click on the search bar by default. Okay, I'll choose that and attach the internet gateway. That's the notation for the internet gateway, that it has successfully attached to that. So far we have completed the phase 1. Now we are moving to the phase 2, which is routing logic. Moving on to the phase 2, folks, we are going to build the routing logic. You can understand routing logic, it's like a bridge. It's like a road which connects the 2 endpoints. Like a routing table will connect with a VPC and the another with a gateway, internet gateway. And for the private network, if you want to download any updates or install any updates, we'll create an ad gateway there and we'll attach that to the private subnets. Gonna build 2 routing tables. One is for the public and another is for the private subnets. Let's build it. For the public route table, I'm gonna give the name of public RT just for the explanation purpose. Let's go and do that. The virtual private cloud only, you can find the route tables here. Create a route table, and you have given the name, and you need to select the VPC. I'm going to select the production Mumbai. That's that, and click on create route table. That's it. We got our route table. We need to attach this road to the VPC. We have attached it to VPC, right? Now we need to connect that VPC to the internet gateway, so the traffic coming from the internet gets to the VPC, from there to the subnet. In this video, I'm not going to talk about the load balancer yet. It will be covered in the upcoming parts of the video. It is just we are creating the core of the cloud architecture. That's that. We have to explicitly mention the target, the route. We have fixed the one endpoint to the VPC, right? We need to fix the other endpoint to the internet. So we're gonna do that. Let us just see how we can do that. Now we are in route tables. As you guys can see, public RT, which stands for public route table, and edit routes. I'll go into that, and I'll add from here to 0/0. It stands for anywhere, and the target would be internet gateway. And this is our internet gateway which we have created earlier. I'll choose that, and I'll save changes. Now we have successfully attached another endpoint to the internet gateway and one endpoint to the VPC. So we are done with the public part. Now we will cover the private route table. There is also, I forgot to mention that we need to associate this subnets to the this route table which we have created to the subnets as well, because in subnets only we are using the resources like EC2 instance, load balancers, and all the stuff, right? So let me just do that first. Let me just go to the route table and click on this, and the subnet associations here, edit subnet associations. Yes, as you guys can see, we have the list of all the subnets in our VPC. I'll attach subnet 2 and public subnet 1 and save the associations. As you guys can see, explicit subnet association, it is showing 2 subnets, right? We are done with the association of subnets. Let's create another route table, which is a private route table. Now we have connected the 2 other endpoints with the route tables in the private subnet as well. Now let's move on to the phase number 3, which is security groups. Why do we need security groups? Security groups nothing but a firewall. It serves as an extra layer of security. It's just that you want to make your system as secure as possible by adding layers of security. So this is security group is also one of the layer. So I'll be creating 2 security groups. One is for the web security group, reason being it is a public, right? It interacts with the internet, and I'll be connecting the HTTP port to it using inbound rules. Keep open the outbound rule as well. Similarly to the private security group, I will not be using the internet gateway. I'll be allowing SSH access both to the private and the public security groups as well. Security groups under security. These are the default security groups given by AWS. Let's create our custom ones and inbound roles. As you guys can see that these are the inbound roles I'll be taking in. I want to allow the SSH access at port number 22, which is from my IP address, my machine IP address. I can access that through my IP address, and another one is from the internet, which is port 80. The request listens on port 80. So I'll do that. Let's see. We have custom TCP, right? I want to listen first HTTP. It takes the port range by default 80, and this is the CIDR block I want to give. This is the inbound rule. I also want to add another rule, which is here is the SSH, which gives the TCP of 22 port range, and in this you can see there is my IP. You don't need to go by default and check out the IP address. AWS does that for you, so you just need to choose the option, and we have done that. Don't delete this outbound rule, okay? Leave it as it may. Don't delete the outbound rule. web security group, and the description is that's that. And the VPC is we want to attach it to the production Mumbai. Now click on create security group. Now we are done with the public. I think I haven't given the name, the security group name. I'll just name it here as well. Just paste the at least okay, so that it would be easy to find. Now let's create our application. Let's say the server side. Take the name from here and paste it here, and it should attach to production Mumbai server. Basically, the security group that is inside the public subnet, if we add that to the private subnet as well, we can communicate between the web server and the backend server as well. Here I have also given the small description for the source. Yes, this is the source, right? This is the source. It is showing me don't choose IP address. Select the web SGD. This ensures your public server can talk to private server. Let's keep it at custom and just search it up. You can see the security group which I have created, WebSG. Choose that. Keep the outbound role similar. Don't change it. And create security group. And we have successfully created the security groups for public server and the application server as well. I'll show you the step-by-step document which I have made it, and I've also added to my GitHub account as well. This is my profile, you can check it out, and I'll just go to my repos. This is the one which I have created, and this is the readme file. You can read it and get the gist of it. And if you see, I have also added the images of what are the steps you need to do, and this is the document for secure two-tier network architecture. If you click here, it will download it, and this is the step-by-step document which I have created for you guys. The reasoning behind why I choose certain steps, and I have followed such a logic, and there is an interesting analogy I have also used so that you don't get bored while reading the document. So now we are done with the phase 3, right, in security groups. We have given HTTP port and SSH access as well. And why did we do this? I have explained it here clearly, and these are the steps which I have given to for you to follow, and how we gonna launch the instances and how we gonna interact between those servers. I'll also show you guys how you're gonna do it. Now let's just get back to the console, and I'll click on EC2. As you guys can see, you'll get the similar screen if you are using the new account, and if you don't have any instances. I'll just get directly into the instance tab. Here it is showing me to launch instance, so we are gonna do it. I'll click on launch instance. I'll just copy paste the name. Where did I left it? I just don't want to type. Reason being because my microphone picks up the clicks of the keyboard, so that's why I prefer to copy and paste the names and all the other stuffs. Where is that? I'll name the public server as Mumbai web server. Here is it. Okay, I'll choose a Amazon Linux as the default. I'm just showing this for an example. You can just play with the options, or you can choose the options as per your requirement. So for right now, this instance type is free tier. It is eligible. T and M falls under the general purpose, which has the balance of both memory and compute as well. So I'll just keep it as default. We need a key pair login, right? If you have already at your local machine, it will just show you, and if not, you can create a new pair with the VPC. Let me just create a new pair. Just name it as production Mumbai VPC, not VPC, EC2. And I'll just name it as key pair. That's that. If you are using Mac, Windows, Linux, PEM is your key file format, and if you are using the older versions of Windows which supports PuTTY, so you can use that the file would be with the .ppk extension. For this demo, I'll be using pem file. Let me just create that. I'll just save it on my desktop. Production Mumbai keeper pem. Okay, as you guys can see, it has automatically taken that. Now you want to edit these settings. I'll just click on to the edit. I want it towards our production Mumbai server, and we are creating a public server right now. So I'll choose the public subnet one, and we want the public IP address, so I'll enable it. Create a security group, no need, because we already have created the security group beforehand. As you can see, there is webs security group. I'll attach that. Storage configuration, we don't need to. There are some advanced details which we can use. I'll show about this in our later point of time videos. So let's skip this for now because we are only working on the architecture. I'll be adding on my upcoming videos load balancer, RDS, auto scaling services, stuff and all. Here we want the single instance, so I'll do that. Launch an instance. We have successfully created an instance. Let's check it out again. Let's get to the EC2, get into the instances. You can say it is up and running. We have launched the EC2 instances. Before going for the testing, we need to check the status. It has to be passed with all the checks. After that, you can try it out by testing the connections between the two subnets. If you try to do that initially before letting it complete that process, you'll eventually find yourself in an error and scratching your head why this came up. So wait for 2 to 3 minutes. It will be done doing its background checks, and it will show you, it will give you a green signal. Okay, it's passed, nothing is wrong with it, you can work on it. And now the private server, which has your databases and all stuff which should not be accessible to the general public. So let's create that. And the only thing you need to be careful is auto assign public IP. You don't need to enable it. So let's launch another, and I'll give the name app server. I'll choose the same Amazon Linux because it is a cheaper. If you think in the perspective of cost, right? So it is a bit cheaper compared to others, and leave the instance type similar. We can use the same key pair. We don't need to create another one. Let me edit this. Change it default to production Mumbai. Private subnet 02, no 01. I need a private 01. Let's keep it disabled. Existing security group. This is the security group, and that's that. Leave the advanced details as it is. Click on launch instance. In an instant, we were able to spin up the servers just like that. Let me just confirm it. If it's working, see, both are in a state of running. As you guys can see, it is showing 3x3 checks passed. So it needs to be completed. The AWS needs to give you a green signal so that you can use that service. So for the application server, it's still doing the initialization. As I've talked about the jump box, right? I have given a definition or the context about what it is and what it's called, why it's called. And now here is the testing part. Here you're gonna test it using a terminal. Let's try using a terminal because we have given the SSH access, right? So instead of clicking onto the buttons in the console, we can just do it in our terminal as well. For that, you need to have a WSL installed in your Windows machine. If not, please do install it. In order to do it, in order to use your Linux commands, you need to enable the WSL or install the WSL from the internet, and install the Ubuntu distribution from the internet as well. So it is already available on my machine, so I'll just crack it up. I'm in my Linux machine, so I'll just get into the location of the pem file which I have created, the key pair. Let me change to my desktop environment. Here it is, as you guys can see. production Mumbai Keeper PEM. It's there. You need to be at that location in order to access it. So otherwise, it's not gonna work. Once you are in your location, then change your file permissions. So crucial. I'll just change it to CMA 400 prod Mumbai Keeper. This gives only the read access of the file so that nobody who is accessing it would be able to change. See, the permissions has been changed. It's all given to the read and execute access only. Now we are going to get into the lobby. We are going to log into the web server. Let's see how that works. For that you need the IP address of the AWS, right? So I'll just get into here. This is our web server. Here is the public IP address. Copy that. We got the IP address right. I'll just SSH I, which is for case sensitivity. I want the PEM file, and then I want to log in as EC2 user at the rate, and I'll be giving the IP address. Once I do that, you can see you have to press yes here. Are you sure you want to continue connecting? Yes sir. And voila, we are inside the IP, or let's say the web server. That's that. Let us just do it by googling it. I'll just type this command curl.google.com, meaning we are trying to ping the Google and check if it resolves the DNS from name to IP address. Actually, let's do that. And if you get this kind of network, right, this kind of output, it means it's working fine. So you don't need to worry what is all this. It means it was able to convert that, it was able to resolve the DNS. So that's that. Public route table is working fine. It is correct. It is exactly what we needed, and the DNS is also working. These are the cases we are validating it. By the way, you need to create another application server. As I have showed you, this is the app server, right? We have already done that. Everything is working fine. We passed the test. As you guys can see, there is no public IP address, correct? Because we haven't provided in our inbound rules stating that it should have an internet access. So that's that. This is its private IP address. It means this subnet is on private IP address. So nobody can on internet can access it directly. You don't need to log out of your web server, because from there only we need to perform the test and confirm the connection between those two. So don't in a hurry try to execute the exit code. So stay on that. Here is the command. In this area you need to have the application server IP address. Let me just copy that. This is our private IP address, and this is the command. N for netcat, nc, this is the options, and it is listening onto the port number 22. Reason being, we are only accessing through SSH, right? We have only given the inbound rule of SSH access, so that's the reason we need to provide the port number. Let me just get into that. Netcat -zv, and the IP address is 22. As you guys can see, it has successfully established the connection. This is the version of it. The status is connected. As you guys can see here clearly, it is showing connected and received point. We haven't sent any data. We're just trying to ping it if it's working, if it's connected or not. Okay, if you don't want to install the network utility tools, there is a SSH way as well. I'll show it to you. I've also mentioned that in this document as well. This is the option 2. You can try it out. You can directly just SSH EC2 and give the public IP address. Yes, permission denied, right? It means success. Reason being, it is not publicly available because it is a private server. We made it private, we didn't give it any public IP address, so it has to show us permission denied. You can check that out, and this is the resource map. Let me also just show you. You guys can see the public subnet is connected to the public route. These two are connected. If the public subnet one fails, it has a fallback option, which is in public subnet 2, which is connected to the route table of the same public route table, which is connected to the internet gateway. That's how you can build a secure structure of your two-tier cloud network. And these are the steps I have given to you guys so that it would be helpful for you to practice. And don't forget to delete all the stuff after you are done with your practice. Reason being, you don't want your surprise of from the AWS that you got a bill of this many dollars, 30K, 40K rupees. So you don't need that surprises, right? So make sure you delete that after practicing it. So yeah, guys, that's the part one for AWS series for high availability cloud network. Stay tuned for more videos. I'll be adding load balancers and different types of load balancers and RDS as well in upcoming videos. See you guys in the next video.